Let's use the addition method to solve this system of equations. First thing you want to do is look at the coefficients in front of the x's. I have 5, 2, and 4. In front of the y's I have 4, -5, and -4. And in front of the z's I have -5, 2, and 4. You want to choose which variable to eliminate. I'm going to choose y because I already have a -4 and a +4 here, so it'll be easy to eliminate y from that pair of equations. And then I'll have to incorporate the 5 to eliminate it from the second one. So what you do is, let's go ahead and take equations 1 and 3 only and see what happens when we add them together. I'm recopying number 1 and number 3. I like to number my equations because it helps me keep track of everything more easily. Alright, so the addition method says that you are able to add two equations together vertically, and the resulting equation will still be part of the system. But what happens when I add, when there is a +4y and a -4y, is that variable adds up to 0 and it eliminates. And that's our goal, is we're trying to work this system down into fewer variables. We're trying to make it easier. So now when I add vertically, I get 9x, my y's are gone, I get -z, and I get -33. I'm going to number that. I'm going to call that equation number 4. That's going to help me later when I want to solve for x and z. But I can't solve yet because I only have one equation in two variables, the variables being x and z. And I need to have two equations in two variables in order to be able to solve it. So I'm going to have to do what I just did one more time, except this time I need to pick a different pair of equations. So I can either do equations 1 and 2, or I can do equations 2 and 3. So I have to still eliminate y though, and so I think I'm going to pick equations 1 and 2 because at least they already have opposite signs. But since 4 and -5 isn't going to add up to 0, I'm going to have to multiply these equations by some numbers to get them so they have the same coefficient, but with opposite signs. So if I multiply the first equation by 5, then I'll get a 20 in this spot. If I multiply the second equation by 4, then I'll get a -20 in this spot, and my y's will eliminate. Okay, I'm going to do that over to the side here. So equation 1, I said I'm going to multiply it by 5, so I like to document that. 5 times equation 1, and I get 25x plus 20y minus 25z equals -45. And then I'm going to multiply times 4 times equation 2, and that's going to give me 8x minus 20y plus 8z equals -36. So again, I add vertically in order to see what I get. 33x, y's are gone, minus 17z equals -81. And I'm going to call that equation 5. And now what we want to do is put equations 4 and 5 together, and we want to redo this. Basically, we want to use the addition property again, but this time we want to either eliminate x or z. Now if we look at the coefficients, on my x's I have a 9 and a 33. Those are not very compatible numbers. And on my z's I have a -1 and a -17. So if I just leave equation 5 the way it is, I could multiply equation 4 by -17, and then I'd get a 17 in this spot. So that's my next step. Just got to logic it out and say what's going to work. I'm going to do a -17 times equation 4. I'm going to write it here so that it'll be underneath equation 5. And so by multiplying each of these numbers by -17, I get, wow, -153x plus 17z, that's what I wanted, 17, but opposite sign, equals 561. All right, one more adding. When we add these two equations 5 and 4 together, now what do we get? In the x spots I get -120x, my z's are gone, equals 480. And so finally I can solve for x just by dividing both sides by negative 120. Phew. So x is equal to negative 4. Now what you do is you back substitute in order to get y and z. I like to back substitute into either equation 4 or equation 5, this one here, with my x equals negative 4. And I think equation 4 looks a little bit smaller number, so I think I'm going to plug x equals 4 into this equation right here, and then I can get z. So 9 times negative 4 minus z equals negative 33. Negative 36 minus z equals negative 33. And so if I add 36 to both sides, I get negative z equals 3. So that gives me z equals negative 3. And then finally, now that I have x and z, I can finally get y, and I just need to go up to one of these three equations. Doesn't matter which one, they're all supposed to have the same solution. That's why we call it a system. So I'll just plug it into the one that looks easiest to solve for y, which I guess I might as well do equation 2. I like the numbers are kind of small. So I'm going to plug x and z into equation 2, okay? So let's see what that looks like now. My equation 2 will be 2 times, here goes in my x is negative 4, minus 5y, plus 2 times, here goes in my z, equals negative 9. And let's do some quick solving. Negative 8 minus 5y minus 6 equals negative 9. So negative 14 minus 5y equals negative 9. Add 14 to both sides. Negative 5y equals positive 5. And so finally, y equals negative 1. And so now that you have all three solved, you can fill in the solution. Just make sure that your solution is in order from x first, negative 4, then y, then z. It's called an ordered triple. Okay, hope that helps. Let me know if you have any questions.